Okay, Geometry, Chapter 10, Section 6, we're looking at segment relationships in circles. So we're going to start off with a circle and a couple of chords. And what the chords are going to do is they're going to intersect each other. Again, it doesn't really matter where they are. The relationship is the same. I don't want to make them appear that they're right angles in any ways because they aren't. And so let's get a quick label on this. Let's call this A, B, C, D, and we'll call the intersection point in the middle E. Okay, so if we have a circle and we have two intersecting chords, their specific pieces are going to have a relationship, and it'll look something like this. Segment AE times E times the other piece of that chord is equal to segment DE times segment EB. Oh, having trouble with E's there. There we go. Okay, so little piece times little piece of one chord is congruent to little piece times little piece of the other chord. And again, that's when you have two chords. So we might also have, we'll go to the next one, we'll go with a tangent and a secant. So let's go tangent and then secant. I'll go ahead and end that one right there. And so let's get a quick label of this one as well. Again, I'm going to stick kind of with the A's, B's, and the C's. There we go. A, that's going to be B, C, and D. And in the case of a tangent and a secant, we are going to square the tangent. So we're going to have AB squared is equal to the exterior piece times the entire, exterior piece of the secant times the entire piece of the secant. So again, tangent squared equals exterior piece of the secant times the entire piece of the secant. And probably should have done the two secants ones first. I'm kind of out of order, but that's okay. So let's go to the next one where we're going to have two secants. And I'm going to go ahead and draw them with endpoints. So we're going to have an endpoint here, endpoint there. Let's label this up. Kind of gave you a little foreshadowing of what's going to happen here. Anytime we have a secant, we're going to take external piece times the entire piece. So what this is going to look like, let me hide that. Actually, let me get a black pen and then hide that. So we are going to take the external piece of the top secant times the entire top secant, and that's going to equal the bottom secant external piece times the bottom secant entire piece. So anytime we have a secant, we're going to take outside times entire. Okay, outside times entire. And that is all. This is a very quick screencast, a little bit under 5 minutes. Chapter 10, Section 6, Segment Relationships in Circles.